Hey YouTubers, Daniel's right here and welcome to A-Level Maths. Today we will consider a Surds problem. So this is the single one. I'm not gonna go through the list of problems, so you can check out my previous videos related to Surds and how to rationalize denominator, because in this question you need to use those skills, okay? The skills about rationalizing irrational expressions, in particular denominator. So that's the main skill that's very applicable to this problem. So this problem was set up as the challenging one, however I don't consider it as it is, and you'll see it why. Okay, so the question is, you need to prove that this expression will be equal to 7 by rationalizing denominator. Alright, so because you have like multiple denominators, and actually what you have here is the sum of those fractions up to the last term. It's not an infinite sum, it's limited by, and here is the final term in the end. So because we have this as the hint, we need to rationalize the denominator. Let's do it right now. So for each expression, what we can do, we can rationalize the denominator by multiplying by conjugated expression. Alright, so for example, I'll show you for the first fraction. It will look like square root of 1 square root of 2 times the conjugated expression, which looks like square root of 1 minus square root of 2. I hope you got the skills, but we need to multiply the numerator of the fraction by the same conjugated expression in order to have the same fraction as it was before. Okay, so right now consider the formula about the sum and the difference. When we multiply out, we'll get the difference of two squares. It's going to be a squared minus b squared, right? And because we have, instead of a and b, we have square root of 1 and square root of 2, by raising the second power, we basically get rid of those square roots. And what we have in the end, we'll get 1 minus 2, which eventually equals to minus 1. Okay, so what we'll have as a result of the first fraction, we'll get square root of 2 minus square root of 1, right? Because the bottom is going to be minus 1, but I put minus in the numerator. So that's why you'll get this. Alright, so if you're applying a similar approach, for example, to the second fraction, you'll get square root of 3 minus square root of 2, okay? And because you sum up all those expressions, let's briefly see what you'll get in the end. So instead of the first fraction, we'll get square root of 2 minus square root of 1. Then we add square root of 3 minus square root of 2. So that's the first fraction. This is the second one. And obviously for the third one, you'll get square root of 4 minus square root of 3. And so on. So we continue this process until we reach the final term, which is in this case is going to be square root of 64 minus square root of 63. And let's see what we can do with that, because we have a certain number of terms here, right? But as you noticed, we have some terms that will be cancelled. For example, let's have a look here. Square root of 2 will be cancelled with minus square root of 2. Square root of 3 will be cancelled with minus square root of 3, okay? And square root of 4 here will be cancelled with minus square root of 4, and so on, okay? Until you reach the final term, which is square root of 64 minus square root of 63, and as you understand, negative square root of 63 will be cancelled with positive term that stays before a sort of previous term, and it's going to be positive 63, okay? So that means it will be cancelled with this term, okay? And eventually you will end up with square root of 64 as the single term left from the last fraction, and with minus square root of 1, which is literally says 1, okay? So finally, if you take the square root of 64, you'll get 8, and minus 1, you'll get 7. This is what exactly you're supposed to prove, okay? The result is 7. And you can consider very different expressions, but finally, eventually, it will be simplified to probably just one number, maybe 2, okay? Depending on initial expression. All right, so I found this I found a similar problem in Alevel Pure 1, and it was set up as challenging. However, as you can see, this is really not. I understand maybe it's all about proof, but the proof is pretty much easier, okay? So I hope after this example, you feel more comfortable and maybe more confident about algebraic structures and algebraic expressions, and especially related to Surds, okay? So I hope you got it. If not, just check my previous videos about how to rationalize denominator. That's definitely the skills that you need to have in your tool, in your assets, okay, in order to apply for similar questions. And also, if you enjoy these math lessons and classes, consider a subscription to my channel and also share your comments, all right? Also, you can check the physics that I explained, and I also continue doing this. Okay, but for those who are interested in more like activities, consider my another channel related to dance, and here's gonna be a quick intro from my channel, from my second channel, so you can find the link in the description below. And now enjoy, so everyone can pick up really good moves from me, or probably just enjoy dancing. All right, check it out right now.